So we're on 484, looking at some 11-4 homework. Number 2 just wanted you to list all of the possible things that might work. Not things that will work, things that might work. So where in the problem do you look to start to generate this list of stuff that maybe could work?
At the end.
Look at the end. What do you do with the number at the end? All the numbers that go into it. So for number 2, what are all the numbers that go into that last number?
4, 3, 6, 2, 1, 12.
I agree. So there's 6 of those. This time it doesn't matter, but where else should we look? The first number. Why doesn't that matter on number 2?
Because it's 1.
Because it's 1. So we want to figure out all the numbers that go into that, but that's useless. And then we could make fractions. Put the last number's factors on top of the beginning number's factors. So for number 2, you're just going to have 1, 2, 3, 4, 6, 12. And then another addition from a friendly voice that just said it, positive and negative. It could be positive or negative, 1, 2, 3, 4, 6, 12. Those might work. They might not, but they might. We didn't have to do this out. We didn't have to figure out who worked. But since it's an x to the 7th problem, how many of those answers could work?
7.
Could have 7 of them work. It's possible. Question about what we did for 2? 4, we'd have a little bit more to our list because at the end, who would be in our mind from looking at 6?
3, 2, 1, 6.
Yep. And then who's in our mind from the beginning?
5, 2, 1, 10.
Correct. So what we'd want to do is create every possible fraction we could create by putting 1, 2, 3, or 6 on the
Chart.
top and putting 1, 2, or 5, or 10
On the bottom.
on the bottom. And then a natural question someone might ask is, should we
Switch the signs.
reduce? And that answer generally is yes. Sometimes when you reduce, it has one that's already there. So should you write that twice or should you ditch one? You should ditch one. So what should survive for the whole numbers is 1, 2, 3, 6. If you put those over 2, if you put 1 over 2, 2 over 2, 3 over 2, 6 over 2, how many of those would survive to stay in your list? 2. Which 2? 1/2, 3/2. If you put those on top of 5, 1, 2, 3, 6, all go on top of 5, how many of those survive? All 4. All 4 of those would survive. 1/5, 2/5, 3/5, 6/5. When you put those over 10 and reduce, how many of those are new? 1, 10, 3/10 are new. So that's your grand total there on 4 is plus or minus 1, 2, 3, 6. The halves, you'd have 1/2, 3/2. The fifths, you'd have a law. 1/5, 2/5, 3/5, 6/5. The tenths, you'd have 2 more, 1/10, 3/10. It does not matter what order you put them in, you just need to make sure you get them all. Question about 2 or 4, how you're figuring out who might make the list? That should be a crazy problem to fully do, because how many answers could this have?
25.
25 answers. Could have 25 answers. We're not going to hunt them, but it could be there. That seems like a better problem to do with some kind of computer program than to do with human abilities.
Well, there's only 24 of the numbers, so,
What do you say?
like,
There's only 24 on the list, but it's actually
yeah, so there's like,
Maybe there's all 24 work plus a quadratic at the
Yeah.
end or something. Or 23 out of 24 work plus a quadratic. Question about first little mini section. Okay, from 6 to 16, we need to try to find all the answers. The x cubed ones are going to have 3. The x to the 4ths are going to have 4. You're going to have to make a guess or 2 from our lists to make something work. And then most of these do make you use the quadratic formula or get something rooty going on. So 6, I'll just say 1 is an answer, and then it's going to give you 2 square rooty answers as the other 2 to get 3. 8, I'll tell you, a whole number works and a fraction works. Anybody have a whole number that works? -1 works. Anybody have a fraction that works? 1/3 works. Then it'll get you a quadratic kind of thing that's going to get you an I. It's going to be this plus or minus I kind of stuff in 8's finish. 10 has two whole numbers that work. Anybody have any whole numbers that'll work on 10? 1 and 2. And then you're going to get a quadratic kind of thing that has a root of 21 going. So if you got some root of 21s going at the end, you're on a good path. 12, there's three whole numbers that work. I'm not going to tell you what they are, but there's three whole numbers that work. It's all numbers that are 5 or less in size, stuff like between 1 and 5 inclusive. 14 only has one whole number hit. Anybody find the whole number hit?
2.
It is 2. And then it'll take you a quadratic to get to the finish line. Your quadratic's going to have an I root 3 thing going. So if you ended up with an I root 3 going, you're probably good. 16, there's one fraction that worked. Anybody 16 get a fraction to work? It is half will work. And then you're going to get a quadratic thing that's going to have root 5s, plus or minus root 5s going in it. Anybody 6 to 16 need more information, or you need me to do one, you need a reteach, remind, enrollment, something about that section, anything?
You need a 6.
6. So we're going to go and have to guess a number from the box. We've got 1, negative 1, negative 3, 3, stuff. So because of this, what are the only numbers that make sense to guess?
3, 1, like plus or minus.
3, 1, positive or negative. I know for a fact before I start
1 is going to
that
work.
1 is going to work.
Yeah.
How do we know that?
If you subtract it all, it makes 0.
Adds up to 0. These numbers all add up to 0, so 1 is going to work. We're going to get a 0 there. So how does synthetic divide start? Drop the 1. 1. 0 because we're adding. 0 because we're multiplying. Negative 3 from adding. Negative 3 from multiplying. Makes us a 0. You good to there?
Yeah.
Since this was x cubed, this is x squared. So you have two choices, three choices. One choice sometimes is try to factor. That won't factor. So a second choice is let that equal 0 and just like try to do opposites, get the thing alone. How would you try to get that alone?
Add 3.
You could add the 3, and then to undo squaring, do a root, and when you do a root, anybody?
Plus or minus.
Plus or minus. So the three answers are this one and those two.
Plus or minus.
Yeah. You okay on that?
Yeah.
Plan B would have been, just do the quadratic formula. 1 is A, 0 is B, C is the negative 3, run the formula from there, that's valid. And that's something you had, most of that section, you had to do the quadratic formula on,
Yeah.
I think all of them except for this one, because the 0 let you off the hook.
Yeah.
And then number 12, it was just all hit factor. Number 12. Anybody else a remind, reteach, anything up to 16? Okay, 17, when it says find only the rational roots, was that good news or bad news? That is good news. What did that mean that was good news? You don't have to do anything weird to get the last answers. So if it was going to take us doing roots or i's or quadratic equations or something, a quadratic formula, something like that, you just bail. So you guess until you run out of guesses, and then you just get out of town. So 18, you should have been able to guess three numbers that are like single hand kind of numbers. There's two positives, there's one negative. You could count them, they're all in size, like single hand kind of numbers. That's what 18 is. 20, because 20 has only positive numbers, you'd only have to guess. If this whole row is all positives, you only guess negatives. So you're going to guess negatives for a little bit on 20. Which negatives would you guess on 20?
2, 4, 1, and 8.
2, 4, 1, and 8. And an interesting thing happens on number 20 when you guess those four negative numbers.
That's what it is?
None of them work.
None
So
of them
you
work.
just say
No answer.
no answer and move on. For number 22 or number 24, one of those two will also have no answer. Okay, so either 23 or 24 is going to take you to a no answer world because you guess everything and it all fails. The other one is going to have one answer work, and it's a fraction. So if you do 22 and you do 24, and one of them you get one fraction and that's all you can find, and then quadratic is like not necessary or going to happen. And the other one you just try everything and you run out of steam, you did that correctly. This paper, when you're giving it to me, shouldn't just have a page of answers. It should have a page of synthetic division that led you to answers, because that's just part of it. 2 and 4 would have had just answers, but 6 to 24 definitely should have some synthetic division, like, stuff. Go. 484, anything I can do to help you understand better what that page is about? Then just flashing back in time, that's the 4th assignment from this chapter. So previous to 484, we also did 478. Previous to 478, we did a 473. Previous to 473, we did a 467. Put that all together, and that's what we have. If you're trying to dodge the hardest one, I think the 3rd assignment was the hardest one, because that was the one that I was making you foil out like half of them, and that it just takes some time to foil some things out. So if you're in terms of budgeting time, I think the 3rd assignment would take the most time. I would think this assignment or the 1st assignment were the 2 quickest ones. The 11-2 was probably like toward the middle somewhere in terms of time and difficulty.